You ever look out at the ocean and just see one of those massive container ships kind of gliding across the horizon? I mean, they're just enormous. These silent giants are the absolute backbone of our global economy. But have you ever wondered how we even build something that colossal? Something that can literally conquer the world's oceans? Well, let's dive in and see how it's done. To really get your head around how important these ships are, just think about this number: nearly 90%. That's right, almost 90% of everything traded globally travels by sea. Your phone, your sneakers, the coffee you drank this morning, chances are it all spent some time on one of these behemoths. They're not just ships, they're the lifeblood of our entire connected world. So how on earth do they do it? In this explainer, we're going to follow the whole journey from start to finish. We'll start with the mind-bending science that keeps these things afloat in the first place. Then we'll watch as raw steel gets forged into massive sections. We'll see the ship actually take shape, see it survive its first tests, and finally, we'll look at the titans of industry who actually build these modern marvels. Okay, so before anyone even thinks about cutting a single piece of steel, a ship is born. But it's born in the world of physics, math, and really, really smart design. It all begins not with a welder's torch, but with the complex science of something called naval architecture. And naval architecture isn't just one thing. It's this delicate, amazing blend of engineering, hydrodynamics. There's even a bit of art to it. But it's all focused on one single goal: creating a vessel that is safe, efficient, and perfectly designed for whatever job it's going to do. And you know, this isn't just some back-of-the-napkin stuff. It is a deeply rigorous field of study. I mean, just look at a university course description like this one. It makes it so clear that students have to master everything from the basic shape of the hull to the super complex physics of stability. And that's all before they even get close to a shipyard. Every single ship design rests on these four pillars. Think of it like this. Hydrostatics is basically, will it float and not tip over when it's just sitting there? Hydrodynamics is all about how it moves through the water. You know, is it efficient? Is it fast? Structures, well, that's its raw strength. Can it handle a 100-foot wave? And arrangements is the floor plan. Where does all the stuff go? You get any one of these wrong, and you've got a recipe for disaster. So, the design is locked in. Now we move from the digital blueprint to the real world, the noisy, sprawling, incredible world of the shipyard. This is where raw materials begin their amazing transformation into a seafaring giant. This quote just captures the whole process perfectly. You see, a ship isn't built all at once. It's pieced together from these enormous pre-made sections. It really is like building with the world's biggest, heaviest, and most complicated Lego blocks. And the process is just so methodical. It all starts with these special steel alloys that are tested for absolutely everything. Then you've got high-precision plasma and laser cutters, guided by 3D models, of course, shaping every single plate down to the millimeter. Next up is welding, and this is so important. They weld everything in a carefully planned sequence to make sure the metal doesn't warp. And every single seam is inspected with things like ultrasound and X-rays to find flaws you can't even see. And finally, all those pieces are put together into these massive units, some of them weighing hundreds of tons. But, you know, not all ships are created equal. When you're talking about the true giants of the sea, the engineering just goes to a whole other level. Compared to a standard ship, their hulls are made of thicker steel, they've got reinforced internal structures, and they have these complex digital systems that are constantly, we're talking real time, monitoring the stress on the entire ship. It's all about surviving those long, punishing voyages across the open ocean. All right, this next part, this is where all that planning and prep work turns into a jaw-dropping spectacle of heavy engineering. This is the moment when all those puzzle pieces finally start coming together. I mean, just picture this. It's like a symphony in a shipyard. Giant gantry cranes, some of the biggest machines on the entire planet, are lifting these mega blocks that weigh hundreds of tons. And the margin for error? It's practically zero. We're talking about fitting these colossal pieces together with a precision of just a few millimeters. That's like parking two buses next to each other with less than the width of a coin separating them. It's just incredible. Once the hull is together, it gets its armor. And let me tell you, painting a ship has almost nothing to do with how it looks. It's all about survival and efficiency. A whole series of complex coatings gets applied. You've got primers to fight off corrosion from the salt water, anti-rust layers, even a special layer with biocide to stop barnacles and other critters from latching on. And that final, smooth coat, that's super important because it reduces drag in the water, which saves an unbelievable amount of fuel over the ship's life. The ship is built. It looks ready to go. But before it can be handed over to its new owner and start its life out on the sea, it has to pass a series of absolutely brutal tests. It has to prove it's worthy. And these tests are no joke. It's not like they just push it into the water and hope for the best. While it's still in the dry dock, every single system is checked and double-checked. Then comes the big moment, the launch. But the ultimate exam is the sea trial. They take the ship out into open water and just push it to its limits. They test its speed, its steering, how fast it can stop, everything. And only after it passes every single test and gets the final stamp of approval is it finally ready for delivery. So, who are the titans of this massive global industry? I mean, where are these incredible machines actually being built? Let's take a quick look at the global leaderboard. Well, it's pretty clear that the shipbuilding world is dominated by just a few key players. South Korea is the undisputed champ, with about 40% of the market. China's right behind them, and Japan is another major force. When you add it all up, these three East Asian nations build the vast majority of the world's ships. And inside those countries, you have the true giants of the industry. Names like Hyundai, Daewoo, and Samsung in South Korea are just legendary. Now, while Asia really dominates in the sheer volume of ships, other countries have carved out their own special niches. Germany, for example, is famous for its focus on super high-tech vessels, like those enormous luxury cruise liners. So, from a simple drawing to a massively complex global industry, the story of the modern ship is really a story of incredible human achievement. But, of course, the story is far from over. These ships really are the invisible engines of our world, quietly carrying the weight of our entire economy on their steel backs. As we look to the future, though, the big challenge remains. Can we build them even bigger? Can we make them smarter, more autonomous, and most importantly, can we make them greener? The only thing we know for sure is that the next generation of ocean giants is already on the drawing board.